Hi, assuming you have a 3D fluorescent stack containing your fluorescent signal spanning over 7 microns here with a scale bar, assuming that we have a step of 0.5 microns, and you want to project this section, the fluorescence of this section, onto a 2D electron micrograph, you will need to flatten your image. To do that, using eC-CLEM, you can just simply start the software, and instead of starting to do your computation, you can pre-process your data. The window that is opening will give you the option to select your active sequence or the fluorescence micrograph of interest. You can decide to apply it to all channels or only the one of interest. Here, for the sake of time, I'll use the quantum dots only. Then you can choose to denoise or not the image. You can make a small makeup or a big makeover and select the size of your element in pixels, so not in size per se. And then you can decide to flatten the image. To flatten the image, you have three options. The first one is to do a maximum intensity projection. This one corresponds to fluorescent signals. You can also do a minimum intensity projection that will, in this case, correspond to transmitted light images. And finally, you can create an optimized in-focus slice using the extended depth of field plugin from EPFL. Once you have selected this, you just run this on the plugin. It will automatically denoise the image and start processing it. It might take you a while depending on your size of the data and the number of channels you have, so you may want to put this on hold or just go for it somewhere else. The image is exported into the ImageJ software system and will be processed there. Once this is processed using the ImageJ from IC, it will be brought back into IC for registration. Now that the image is finished processing, as you can see, the fluorescence is only on one single plane, everything being projected as an optimized focus. You can use the projection of it to do your fluorescence